observe evidence of enormous pressures, intense heating, and violent impacts that occurred billions of years ago. To understand how nanodiamonds form, we first need to understand what a diamond is. Diamond is a crystalline form of carbon. In ordinary graphite, carbon atoms are arranged in flat layers that can slide over one another. In diamond, however, each carbon atom is tightly bonded to 4 neighboring atoms in a rigid 3-dimensional structure. This arrangement makes diamond exceptionally hard. It also requires a very specific combination of pressure, temperature, and time to form. Nanodiamonds are simply diamond crystals at the nanoscale. A nanometer is 1/1000th of a meter. A typical nanodiamond may contain only a few hundred, or perhaps several thousand, carbon atoms. Because these crystals are so small, they can behave differently from large diamonds. Their surfaces are extremely important, and they may contain defects, impurities, and unusual atomic arrangements that record the conditions under which they formed. Now let us imagine the setting. An asteroid is traveling through space at many kilometers per second. It enters the atmosphere of a planet, or it may strike the surface directly if the atmosphere is thin. At the moment of impact, the asteroid and the target rock are compressed almost instantaneously. A powerful shock wave moves through both materials. For a brief moment, pressure can rise to many tens of gigapascals, or even higher. Temperatures can also climb to several thousand degrees Celsius. This shock wave changes the structure of matter in an instant. Minerals fracture, melt, vaporize, and react with one another. Carbon-bearing materials, such as graphite, organic compounds, carbonates, or carbon-rich minerals, can be transformed by the extreme conditions. Under the very high pressure produced by the impact, carbon atoms are forced into much closer contact. Some of them reorganize into the compact, 3-dimensional structure of diamond. There are several possible pathways for this transformation. One pathway is known as shock conversion. In this process, graphite or another carbon-rich material is directly compressed by the impact shock. If the pressure and temperature fall within the appropriate range, part of the carbon lattice collapses and rearranges into diamond. Because the event is so rapid, the crystals often remain very small. Instead of growing into large gemstones, they form as clusters of nanodiamonds trapped inside the shock material. A second pathway can involve carbon vapor or carbon dissolved in an impact melt. During the impact, some material becomes a hot, dense fluid or vapor. As the pressure drops and the material begins to cool, carbon atoms can nucleate, meaning that they gather into tiny stable clusters. These clusters then grow